In this video, we will talk about VLAN and trunking application in campus network. A virtual local area network, VLAN, is a network technology that allows you to segment a physical network into multiple virtual networks. This means you can group devices into separate networks even if they are connected to the same physical switch. So VLANs help improve network management, enhance security, and optimize traffic flow by isolating different types of network traffic. So a VLAN, guys, works in the same way as a physical local area network, with the exception that the hosts don't need to be located on the same physical network to be linked. So segmentation is the division of the network into groups, both for connecting specific groups with each other regardless of network affiliation, and for isolation of groups for security reasons. So using a best practices approach to segmentation makes it possible to maximize bandwidth use while securing sensitive data. So VLANs can be segmented due to traffic patterns, traffic types, geographic groups, or the departments. In a network design, guys, a network admin can design a campus network with one of two modes, and they are local VLANs and end-to-end VLANs. In the local VLAN model, the local switch is connected to a distribution or core switch, and this is where the routing is performed. So local VLANs will only exist between the local switch, which is the access one, and the distribution or the core switch. In this model, you use different VLANs for different geographical locations only. And we have the end-to-end VLANs. These are dispersed throughout the network on multiple switches. So no matter where the user plugs in, they will always be assigned the same VLAN membership, and the resources for this user will be on the same subnet. So management of end-to-end VLANs typically use VTP through trunked switches, and this allows for easier management. Guys, in networking, access ports and the trunk ports are types of switch ports used to handle different kinds of traffic within VLAN configurations. An access port is a switch port configured to carry traffic for a single VLAN only. So it is used to connect end devices like computers, printers to the network, and all traffic from an access port is tagged with the VLAN ID assigned to that port. The port does not add VLAN tags to the frames. It sends out or removes VLAN tags from frames it receives. So the frames are sent in an untagged format. Okay. On the other hand, a trunk port is a switch port configured to carry traffic for multiple VLANs simultaneously. So trunk ports use VLAN tags to identify which VLAN a frame belongs to, allowing a single physical link to carry traffic from multiple VLANs. Frames traveling through a trunk port have VLAN tags added by the sending switch and are identified accordingly by the receiving switch. So typical use case for a trunk port, it is used to connect switches together, allowing them to share VLAN information and the traffic. In VLAN configuration, guys, VLAN ranges define the scope of VLAN IDs available for the use on the network devices. So for example, VLANs between 1 to 1005 represents the standard VLAN range. So this range is typically used for in smaller or less complex networks, and it includes VLAN IDs that are supported by older networking equipment and most Cisco devices. So VLAN 1, that is the default VLAN on many switches, And VLANs between 1002 and 1005 are reserved for legacy token ring and FDDI networks. And we have also the extended VLAN range that is between 1025 and 4094. It is used in larger or more complex networks requiring a higher number of VLANs. So it is available on more modern switches and typically used for additional VLANs beyond the standard range. This range is often used in environments that need more VLAN segmentation, guys. And the availability of extended VLANs can depend on switch model and the configuration. And now let's have a look how we are configuring the VLANs. On switch 1, I have gig 01 and gig 02 as well as the gig 03 interfaces. Gig 01 is belonging to VLAN 100, gig 02 is belonging to VLAN 200, and gig 03 is the trunk port for the switch. So how I would configure this switch regarding this topology? First of all, I need to go ahead, create my VLANs and name them. For example, VLAN 100, name IT, exit. VLAN 200, name HR, exit. This is where I'm going ahead and creating my VLANs as you can see in here. Then I'm going into my interface mode by typing interface and the name of the interface like this. And then I am typing my switch port modes as access for gig 01 and gig 02 interfaces. Switch port mode access. Switch port mode access. Why I am typing access? Because these ports are carrying just one single VLAN. Then I am going ahead and typing switch port access VLAN and the VLAN ID that I will assign this port. Same applies for gig 02. I'm going ahead and I'm typing switch port access VLAN 200, which is the VLAN for this interface. But what I will do for gig 03? Gig 03 is responsible to carry multiple VLANs. It needs to carry VLAN 100 as well as VLAN 200, right? So I'm going into the interface mode, gig 03, and I am typing switch port trunk encapsulation, and I am picking my encapsulation. In this case, I'm picking .1Q, and I will tell you what are the differences between .1Q and the ISL. Then I'm going ahead and defining my switch port mode. In this case, it is not an access port, that is a trunk port, since it will carry multiple VLAN information. And then I'm defining which VLANs this port is carrying. Okay, switch port trunk allowed VLAN 100 and 200 for this example. Trunking protocols are used to carry multiple VLANs over a single network link. So the two primary trunking protocols are .1Q and the ISL, guys. So ISL, that is a Cisco proprietary trunking protocol developed by Cisco, and it encapsulates Ethernet frames with a header that includes the VLAN information. Okay. On the other hand, .1Q, that is an industry standard trunking protocol for VLAN tagging. It adds a 4-byte VLAN tag to the Ethernet frames, indicating the VLAN ID and other information. So .1Q basically, guys, inserts a VLAN tag into the Ethernet frames header between the source MAC address and the ether type fields. And it is widely supported across various network equipments and vendors, making it more versatile and commonly used than ISL. Now, on the upper side of the screen, you are seeing the ISL header. In the below, you are seeing the .1Q header. .1Q has less frame load than ISL. So as a result, .1Q is more effective than ISL, especially in small frames. So when the .1q load is only 4 bytes, ISL is 30 bytes, guys. So today, mainly the .1q is being used in modern networks. And we have the .1q native VLAN term. So in .1q trunking, the native VLAN is a special VLAN that handles untagged traffic on a trunk link. Okay, so the native VLAN is the VLAN assigned to carry frames that do not have a VLAN tag when they are transmitted over a trunk link. So when a switch port is configured as a trunk, it sends and receives frames with VLAN tags for all VLANs except for the native VLAN, guys. So frames belonging to the native VLAN are transmitted without VLAN tags. So this allows for backward compatibility with devices that do not understand VLAN tagging. It also simplifies communication between devices on the same native VLAN across trunk links. So on Cisco switches, the default native VLAN is VLAN 1, but this can be changed to another VLAN as needed. Okay, so changing the native VLAN from its default can help prevent VLAN hopping attacks, where an attacker could potentially send untagged traffic into a different VLAN. So if you just want to change the native VLAN on a Cisco switch, here's the command: switch port, trunk, native VLAN, and you are typing the VLAN ID for the native VLAN. That's it. To verify the trunk ports, the command I am using is show interfaces, interface name, and the switch port. Okay, it will show me the administrative mode if it is trunk or not. It will show me operational mode if it is trunk or not, and it will show me which encapsulation type I am using and negotiation of trunking is on or not, and other useful stuff. And another useful command to verify the trunk operation is show interfaces trunk. It will show again which encapsulation is being used, status if trunking or not, native VLAN information, and VLANs allowed on this trunk. You can see by typing show interfaces trunk command. And let's continue with the dynamic trunking protocol, DTP. That is a proprietary networking protocol developed by Cisco again for the purpose of negotiating trunk on a link between two VLAN aware switches and for negotiating the type of trunking encapsulation to be used. It works on layer 2 of the OSI model, and VLAN trunks formed using DTP may utilize either .1q or ISL trunking protocols. Okay, so in DTP, guys, we have mainly 4 different switch port mode settings, and they are access, trunk, dynamic auto, and dynamic desirable. Access, guys, puts the Ethernet port into permanent non-trunking mode and negotiates to convert the link into a non-trunk link. So the Ethernet port becomes a non-trunk port even if the neighboring port does not agree to change. On the other hand, trunk puts the Ethernet port into permanent trunking mode and negotiates to convert the link into a trunk link. So the port becomes a trunk port even if the neighboring port does not agree to change it. We have dynamic auto, which makes the Ethernet port willing to convert the link to a trunk link. So the port becomes a trunk if the neighboring port is set to trunk or dynamic desirable mode. This is the default mode for all Ethernet ports. And we have the dynamic desirable, which makes the port actively attempt to convert the link to a trunk link. So the port becomes a trunk port if the neighboring Ethernet port is set to trunk, dynamic desirable, or dynamic auto mode. So let's say I have 2 different switches. Okay, switch 1, it is connected to switch 2. And I would like to create a trunk link between these switches. Okay, let's say this is gonna be my trunk link. How I can create my trunk link? There are two ways. The first one is the manual one that I have showed you already, and the second one is by using DTP. So if you are using DTP, you need to make sure for these ports connecting to each other, okay, let's say port 1 of switch 1 and port 2 of switch 2. So if you just want to establish a trunk link, you need to refer this diagram. Okay, so for example, if you just go ahead and configure the switch 1 port as a trunk and switch to port 2 as a trunk as well, then you will end up with a trunk link. Yeah, it is good. But on the other hand, if you go ahead and configure switch 1 port 1 as dynamic auto, for example, and if you go ahead and configure switch 2 port 2 as dynamic auto as well, then you will end up an access port. You cannot go ahead and configure a trunk link with two sides configured as dynamic auto. So you need to somehow memorize this chart, guys. I explained you how it works really, but again, it is a good idea to memorize all those stuff and be aware of which port modes are creating a trunk and which port modes are not creating a trunk. And lastly, let's talk about some of the best practices. First of all, we need to avoid using VLAN 1. So VLAN 1 is the default native VLAN for Cisco switches, and don't forget this one, guys. Everything remained in the default mode can be a subject to an attack. Okay, so it is not secure to use VLAN 1, first of all. The second one is better you go ahead and configure the trunk ports manually. Okay, otherwise you will need to memorize all these charts that I showed you. So in some cases you may end up with an access port when you are trying to configure a trunk port by using the DTP. Okay, the third thing is we need to use .1Q instead of ISL because .1Q is more effective, as I told you. Always use SSH instead of Telnet when you are trying to, access your devices remotely, because SSH is more secure and encrypts the communication, as you know. And the last thing is make native VLAN different from VLAN 1 to prevent the DTP spoofing attacks. Okay guys, thank you so much for joining me in this section, and let's see you in our next lessons.